In this video, we will learn how to find slope of isoquant. The question is a given production function that is f of lk, which means production is a function of labor and capital, which is equal to L to the power 1 upon 3, K to the power 3 upon 4. Find the slope of the isoquant passing through the combinations of labor and capital is 20 and 40. The options are being given. We need to find out the correct option. Okay. So basically, what is meant by isoquant? Isoquant is, an isoquant is a locus of points, or we can say an isoquant is a contour line drawn through the set of points at which the same output is produced while changing the quantities of inputs. In simple words, let me draw it here. So let us say we have units of labor on the horizontal axis, units of capital on the vertical axis, and and this curve is actually called isoquant. Okay, this curve is called isoquant. It shows us different combinations of factors of capital and labor, okay, which produce same output. Each point on this curve shows the same output. Okay, we are just only changing the combinations of capital and labor. Simple, it shows different combinations of labor and capital which produce same level of output. That is meant by the isoquant. We need to find out the slope of this very isoquant. Now, how do we find? Let us say here we have to fix, to find out the slope, we need to hold quantity fixed, output fixed, and let me write it here. Fixing quantity. Okay, we hold quantity fixed. Let's write the general Cobb-Douglas production function here first. We know that f of lk, let's denote it by q. Let us hold the quantity fixed is a function of L to the power b, k to the power a. Okay, simple. In place of 1 upon 3, I have b, 3 upon 4. I am just writing the general formula here. Okay, I will explain how do we derive the slope. So if let us solve it for k. If I solve it for k, and let me use another color. If I solve it for k, which means k to the power a will be equal to q bar times, if I transpose, it will get divided, and if I transpose it to the numerator, then it will become L to the power minus b. Okay, I'm just saving some steps here. It will get messy then, which implies k will be equal to, our k will be equal to q bar raised power 1 upon a. Okay, this exponent, when transposed, it will get reciprocated, and we have L to the power minus b upon a. Okay, so this is our k. Now what is slope? Slope is simply, let me write it here. Slope is being given as the marginal rate of technical substitution between two inputs, which is equal to dk upon dl. Okay, which is actually equal to marginal product of labor divided by marginal product of capital. Okay, so slope simply shows us how many units of capital I have to sacrifice for an additional unit of labor so that I get same output level. I am fixing the quantity and simply changing the combinations of capital and labor. That gives us the slope of the marginal rate of slope of the isoquant. Okay, so actually I need to find out this dk upon dl here. So let's differentiate this function with respect to L, which means dk upon dl will be equal to, if I take derivative, I am just taking derivative with respect to L. Okay, here remember, we are not differentiating with respect to q, since we want it to be fixed for different combinations of inputs, which implies we will have dk upon dl. And what is derivative of L to the power minus b upon a? So minus b upon a will become coefficient q bar. We have 1 upon a L to the power minus B upon A minus 1. Okay, by power function rule, solving it further, we will get minus B upon A Q to the power minus 1 upon A. So cross multiplying, we will get here L to the power minus B minus A divided by A. Okay, so this is our dk upon dl. Now let's give the value of q, since q is equal to this stuff. Let me write it here. So our dk upon dl will be equal to minus b divided by a. In place of q, we have l to the power b, k to the power a. Okay, so we have l to the power b, you know, k to the power a raised power, so it is here bar. Okay, so we have 1 upon a, l to the power minus b minus a divided by a. Okay, which implies dk upon dl will be equal to minus b upon a. Now expand it, we have l to the power b divided by a, k to the power a divided by a. Then we have l to the power minus b minus a divided by a. So which gives us minus b upon a. We have same basis here. I can add up the exponents. We have b upon a minus b minus a, okay, divided by a, and we have k, a and a gets cancelled, k to the power 1. Solving it further, we will get minus b upon a. Here minus a, sorry, b minus b gets cancelled. Then we have l to the power, okay, we have common denominator here. We can add up the numerator here. So we have minus a divided by a minus a divided by a k, which is dk upon dl will be equal to minus b upon a. A and a gets cancelled. We have l to the power minus 1 and we have k. Writing further, we have minus b upon a, k, transposing it to denominator, exponent sign gets changed. Now let's give the values of b and a. B is 1 upon 3. Okay, so in place of b we have 1 upon 3, so we have minus here 1 upon 3 divided by a. A is 3 upon 4, 3 upon 4. K is being given us as 20. Sorry, k is being given 40, so we have 40 divided by 20. Okay, solving it, we will get dk upon dl is equal to we have minus 1 upon 3 into 4 divided by 3. When I transpose, it will get multiplied and reciprocated into 4 divided by 2, which comes out to be 4 4s are 16, which is minus 16 divided by 3 3s are 9, 2s are 18, which comes out to be 2 8s are 16, 2 9s are 18. That means the slope of the isoquant will be, let us say we have here L is 20, K is 40. Okay, at this point the slope of this isoquant is minus 8 divided by 9, and this minus sign actually shows us, actually MRTS is minus dk upon dl, which shows there is we have what we call uh, negative slope, or our isoquant is downward sloping. And how do we interpret this? Dk upon dl is equal to minus 8 by 9. So dk upon dl is equal to minus 8 by 9. Okay, it simply tells us to produce same level of quantity, we need to sacrifice, how many units? 8 units of capital for